Welcome. Today I want to talk about comparing generated code from OpenAPI-generator and gRPC and how they may be used with Go. Let's start at the very beginning. Add two numbers. What's wrong with this code? By the way, it runs. Let's see. Yep, it runs. Well, shouldn't it use functions? So let's create a function here. And true enough, it runs as well. But shouldn't functions be in a library? So let's create a library in this package called arith, and this is how we call the library. And let's run the code. And it runs. Let's make it slightly bigger. Okay. So we live in a world where microservices is in fashion. And two major initiatives are REST or HTTP JSON APIs specified in OpenAPI or Swagger, or Google's remote procedure call facility called gRPC. Let's first start with OpenAPI. The reference is given in this link. So we can actually write our OpenAPI or Swagger specification with this online editor provided by Swagger. Thank you, Swagger. And the specification looks like this, which we'll look at in a while. Actually, we'll look at right now. That's not that. Copy. I hit Control Shift rather than, okay. So it is OpenAPI. Right now it's at 3.03, but I'm using 3.02, it's roughly there. Here is the metadata block. There's some information, the title, the version number. This is where we will contact the server. In this case, the server is my local computer, localhost, port 8080. And here are the API paths. I've just defined one path to keep it simple, and it's called sum, and it's a GET request. There are two parameters, num1, num2, and those parameters are in the query. The schema of num1 is an integer 64, which is defined here. int64, type integer, format int64. The response, a successful 200 response, would be a sum response, which is an object with a property or field sum of type int64. The sample would be, let's say, the number 5. So as a learning exercise, I hand wrote from scratch a Go server that implemented the sum service. This is 100% native Go standard library. So here is the sum endpoint, and the request is passed. And notice that I had to use conversions from strings to integer, because that's what HTTP JSON is, passing around strings. And if I could not pass the string, I return an error saying I could not pass that integer. And the return code is 400. We all know 404. 400 is bad request. In the case of a good request, we set the content type to JSON, application JSON. And instead of using the JSON encoder, I just hard-coded a JSON object saying that the sum is a plus b. This is my small little library which connects to port 8080 if the port environment variable is not otherwise defined, and it listens to that port. Let's test the API and server. We first run my handwritten server, Control C, go over to my dual pane and run my handwritten server, which is running in Go. It's up and running. Good. So if you go to the Swagger API's editor's right-hand pane, under the arithmetic group, get some, try it out, execute, we have this convenient curl string, which I will copy and paste into the upper window. So it says num1 is 1, num2 is 3, the sum of those two should be 5, and true enough, it's 5. Just to make sure that that number is not hard-coded, let's copy this again, repaste it, and let's change this to 33. And the sum is now 35. So it's not hard-coded. It's good. I benchmarked this using Apache Bench. 2,000 requests with a concurrency level of 8. It took about 0.4 seconds. And I managed to get about 5,000 requests per second. This was on a 4-core i3 laptop, and the 99th percentile took 5 milliseconds to respond. The longest request took 9 milliseconds. The Swagger editor is very powerful. It allows you to generate client and server code stubs within the editor itself, but I will use an open source project called OpenAPI-generator instead. The OpenAPI-generator provides Docker images, and I'm using version 4.1.3 to generate the client as well as the server stub. If you run these commands, you will find generated files in my case, my home directory, downloads, temp, arith, because it's marked here and mapped to H. The latest version of OpenAPI-generator is 5.00 beta 3. I tried it, but it broke my server stub because of type incompatibility. So I went back to 4.1.3. How do we use the OpenAPI generated client? Remember, those files were in my home directory. We first need to copy it into a subfolder called client. And when I go into the subfolder and list the files, I see all these files. There are some files which I don't need because it's under my main module, which already has a Go mod and a Go sum, so I need to remove these two. And it's already under a larger Git repository, so I don't need that git push shell. So I'll remove it thus. The client is created. I created a new main command called client, and that is how it is defined. So starts off by saying arith API client. And the client is a new API client with a new configuration. And here I'm calling the arithmetic API sum get. The context is for you to have timeouts or pass context-wide parameters, context-wide values. But in this case, I just pass a context to do to remind myself we can pass a context. You could also pass context.background here. And here are my two parameters, 2 and 3. If there's no error, I'll go ahead and print that the sum of 2 and 3 is hopefully 5. So let's run it. Clear this. So right now I'm running the OpenAPI-generated client. And good enough. It is indeed 5. Now let's complete the OpenAPI-generated server stub. Remember, the code was generated in my home folder. I'll copy it into a subfolder called command server. And if I list command server, let's do that. I have those files. There is a main Go in there. Oh, by the way, that reminded me. The definition of the OpenAPI is given here. Yeah, I think we went through that. Right, this is how we implement the server. The server just provided these two lines, set content type and HTTP OK, plus the some get declaration. I had to provide this implementation. Basically, everything from my handwritten server, but copied and pasted into this function over here. It's exactly the same. And this is the implementation where A is added to B. Let's run the generated server. The server should be at the lower half. Let's clear that. And the generated server has started with a nice log message. Before we do the benchmarks, let's run the client again. Okay. The client still works, and it took 12 microseconds. Let's see whether curl still works. Curl still works and the sum is still correct. Good. So the concurrency level 8 took slightly longer, about half a second for 2000 requests, running at about almost 4000 requests per second. I have a 4-core laptop, so 8 is overloading it slightly. Using a single core with a concurrency level of 1, it takes about, provides about 2000 requests per second. Keep that in mind. We'll compare it with gRPC next. But here are a few notes about using OpenAPI with Go. First, we need to learn OpenAPI. We need to read the API specifications and write them in YAML. The online editor provided by Swagger is great. It's a convenient online editor and it validates as well. The generated client is easy to use. All you need to do is call new API client, new configuration, and call it with the whatever functions you define in your API. The server stub is very minimal indeed, and you effectively have to provide your entire implementation in the Go subfolder of your API.go. Now let's talk about gRPC. It is an open source project contributed by Google. It's now open source. And it uses protocol buffers instead of JSON to serialize messages. Protocol buffers is a binary protocol, and it's more efficient than text-based JSON. There are some prerequisites to set up. You need to download protocol compiler, the gRPC plugin for Go. It's all given in this link. First, like in our OpenAPI definition, we need to create the specifications. The specifications is written in protocol buffer. Here we are using protocol buffer version 3. There is an option to define the Go package, which is what I've defined here. The service is called arith, A-R-I-T-H, and there is one service call within the arithmetic server called sum. It takes a sum request and it returns a sum response. Sum request comprises of two parameters, A and B, and sum response comprises of one parameter, sum. Now these ones and twos are, think of them as slot numbers. They are index IDs. They are not assignments, not A assigned to 1. No. It's A is in position 1, B is in position 2, and I think positions 1 to 8 or 1 to 16 are more optimized, faster for gRPC. Here is how the code is generated. I create a subfolder called gRPC. I invoke the proto-C, the protocol compiler, to output my protocol buffer definitions in gRPC, to also output my gRPC definitions also in gRPC, and my source file is proto-arith.proto, the one you saw just now, this file. And when I list the contents of gRPC after I run the protocol generation, there's a single subfolder within it, which comprises of the protocol buffer definitions and the gRPC definitions. Here is how I implement the gRPC sum service. Well, it's a gRPC arithmetic server. There can be one or more service calls, and in this case the service call is called sum. It takes a context and a request, sum request, and returns a sum response and a go error message. It prints to the log that is receive parameters A and B. These are defined automatically by, or generated automatically by the protocol compiler. So this is your A parameter and B parameter, and it returns some response A plus B. No error, nil. So as I said, sum, get A and get B are generated from the proto file. There is some boilerplate, but it's quite easy to understand. In the main function, I say it's launching this arith server, connecting to port 551. If I cannot connect, it fatals out. It registers a new server, and we are up and running. So let's run the gRPC server. And the gRPC server is up and running. Here is how we use the generated gRPC client. We first dial to localhost 551. If you can't connect, log an error message. And here is the new arithmetic client. using that connection. I make context with a timeout of 1 second, and I call the sum service with this sum request with a equals 2 and b equals 3. And finally, I print out that the sum is hopefully 5. Get sum is again generated from the protocol definition, the protocol buffer definition. Let's run the client. So I'm running the gRPC generated client, and yes, it provided the correct answer. Of course it did. We can't benchmark the gRPC arithmetic service with Apache Bench or any curl or Postman-like tools, so I had to write a small benchmarking program. The benchmarking program is essentially the client itself, but here I call the client the sum service 2000 times and record how long it took to define the request per second. If I run the benchmark, it says, well, when I last run it, it was about 3000 requests per second. It took about 0.7 seconds. Let's run it again for good measure. So I'm running the benchmark. Now it took almost 2 seconds. It's almost only 1000 requests per second. Why? Because I'm recording this video. Let's run it again. Yeah, about there. So with my CPU running, recording this video, it could only manage about 1000 requests per second. But without recording the video, about almost 3000 requests per second. If I compare this with the OpenAPI, that could only manage about 1008 requests, close to 2000. This is slightly faster, 3000. So what's the difference with using gRPC with Go? First, we need to learn the protocol buffer language to define the proto interface files. Using the generated client is quite simple. You call your API client, give it a connection, then you call your service and give it your parameters. Fleshing out the server stub is simpler, much simpler than with OpenAPI generation, because there are no conversions to and from strings. It's native Go. There is a drawback. You cannot use curl to test the service. If you would like to replicate what I have demonstrated in this video, you can download the presentation and the code from my GitHub repository. Thank you.